Hi, students. Welcome to the latest edition of Academy exclusive podcast series. Like with every session, we are trying to bring someone who is going to inspire you and who is going to build a new perspective for you. So, this week we have Mr. Abhinav. So, he is working in Twitter as a software development engineer and he has a vast experience of working with many companies. So, right after his college, he joined Cisco, and post that he worked in Amazon, and he worked for a gaming company called Kiwi, and he also worked on his own startup. Post that he moved to Booking.com, and right now he's working in Twitter. So in multiple domains and across some of the world's best companies, over the time he has gained a lot of exposure on how things are being built and how software development works. So the theme for today is uh, how software development process works and how software development actually works in companies like Twitter. So he's going to give you some new perspective, not big jargon or not to scare you about with the process and all, but we hope this session is going to bring you a newer perspective about what a piece of software is and how you should see it and how you should work with it. Yeah. So Abhinav is with us and he's joining from Netherlands. So he works at Twitter Amsterdam. So after his busy and hectic day, he's joining us. Thank you so much, Abhinav, for joining us today. So we have thousands of students who are waiting very eagerly to listen to what you're going to talk about. So we had a very interesting theme today. It's about unbundling the software development process, which happens in industry. So generally we hear many things around it, but it's the first time they are trying to understand it from a person who has a very vast experience in working in multiple companies and dealing with large code bases and all. So we can start off into the conversation. And just before that, I wanted to introduce our students to you. So they are very aspiring students. They are, they always find a way to learn new things in addition to their college curriculum and all. So they fit in time to learn programming. Okay, right in their first year and second year. So they're very consistent and they have been they have been showing us like many interesting things from what they have learned. Okay, and bi-weekly or once in a month, we kind of conduct these podcasts where they get to learn a new perspective from the industry experts like you. So, yeah, I think thanks again for joining us today.
Yeah, I'm happy to join. And yeah, I'm really happy that I could share my journey and my thoughts.
I think definitely that will be helpful to many of the students. So I want to start off. Abhinav has been a very good friend to me. So we have known each other from very long time. So he's one of the most charismatic persons whom I have seen in my life. So I want all of the students to understand a little bit about your thinking process or your kind of ambition you used to have and the rigor you show. So that I will try to capture that by asking some questions. So feel free to answer them in your own style.
Sure. It's actually likewise. So I find you really charismatic. So like you travel with a lot of people. So I travel with you and I kind of know what you are. So likewise, it's.
Yeah, and coming back to the topic of today, like for example, software development. So, what inspired you to build a career into software development? Like, what was your journey like? How was it like? I mean, I know you have been building applications before Android has rolled out. So, it was a really long time ago. And I know you have been working on web applications before there was any framework. So, what inspired you? What is software for you?
I always try to think like where it started, but so one specific example that I could remember is like in like ninth grade or something. Like I was really fond of prime numbers, so I was really like Like I really wanted to find out an equation, what makes a prime number. So I used one calculator and was trying to figure out an equation, like given two numbers, how can I derive a prime number out of it? So, and then, it was back in those days where I didn't know about computer. And then I loved the process basically. So, and then I tried to email the author of this prime number book. Out of this is like completely naive me, like 20 years ago, something like that.
Okay.
And then, I tried to email. So that is when I went to an internet cafe and then I basically just tried to email that guy. Then that is the first time I basically know about computers. So that was my first inception. And then, I got to know about Word, and then you could draw like geometry diagrams and stuff in these Word diagrams. So I used to use my brother's computer, cousin brother's. And that is where like I got to know about computers and what software are and all these things. So that is when
exactly during the very early days of mass adoption of computers and internet, right?
Yeah. So computers weren't like very common. So it was like 1 in every 10 houses we probably used to find or something like that. It's not common at all at that time.
Yeah. Yes. I don't want us to sound very good, but I think these are facts. So.
Yeah.
And, true. I mean, it has been a long journey, I believe, like from where you have started trying to understand the process behind a particular problem to dealing with millions of lines of code in multiple companies. So you have, I mean, from today in the next 30 minutes, so we'll try to understand like how software development happens in large companies like Twitter. Okay, so Twitter is one of the top 5 or top 10 companies in the world. So they're known for its innovation and their success and the change it has made across different spheres of everyone's life, right? So can you briefly tell about what is software development and how it happens in in companies like Twitter?
I'll put my take out. So everybody has a different take on like what software is. Like for me, it's like any piece of code is a software. So even like 10 lines or 20 lines, it has some input and it has some output, is a software. And it naturally evolves. Like it has some specific purpose, right? So, and the purpose evolves really big, and sometimes the purpose is really vague. So, for example, like you take about Twitter, for example, Twitter is basically an interest graph. So you have your own interest and it will try to give you all those interests that you might like. And people who tweet about it, like they basically the tweets are presented to you based on your interests and this kind of thing. So it is an interest graph. For example, Facebook has a different motivation. So that piece of software basically is trying to make the world a little more connected. And the purpose of the software is like broadcasting yourself to your friends, right? Sometimes the specification of that software is like really concrete. It does like add 2 numbers or something. Sometimes it's very vague. Sometimes it's very generic. And I think the purpose of software can be anything. For example, you take an AI, it's a very complicated process what it does. Anything is a software and it basically evolves based on its purpose. It basically keeps on expanding and evolving. So in a generic terminology, they call like each has an interaction surface area. Like for example, Twitter, you have like web, Android, and different kinds of interaction surfaces, right? So each surfaces, So that's how you interact with the software. Software does its thing and it does something in the background. And it's always an evolution. So for me, my take on software is basically any piece of code is a software.
Any piece of code which does something and which has a purpose. Even if it is adding 2 numbers or to connecting you with your friends who has similar interests.
Yeah, that's it. For me, yes.
And also, definitely it makes sense. And it depends on why you are building and what you are building for will make the scale of the development process bigger and complicated.
Absolutely. Because connecting people is a very complicated piece of software because it's not a clear-cut specification, right? So it's a very big vision. So companies have visions. So they don't have like a specific purpose or specification of it. So they always like keep expanding, keep figuring it out. There's always a feedback loop that changes the software. So I look at software like an organism. Like it has its own life. Every line of code basically runs millions and billions of times. So it's very natural for me. Yeah, the
So
way I look at it.
it's as natural as the process of evolution. So
Yeah, absolutely. Yes.
okay, so each software will have a purpose, and based on the purpose, so it will start somewhere,
Yeah.
but continues to evolve. And based on if it is
Yeah.
evolving with the, evolving over the time, then I think it's going to stay for more time compared to what evolves. So
Others. Yeah. Yeah.
okay.
Yeah. So some software that I have written is never used, right? So for example, like it basically died. That's it. But some software, they live forever. Like the core, for example, like a booking process or core of connecting friends or core interest graph, they live forever. They are the strongest pieces of software that have been written. So if you take any big company, it's almost like millions or like 100 million lines of code. Like, for example, like Google or Facebook, they probably have churned like 100 million lines of code. Or if you take your over 100 million lines of code, yes. Yes.
Okay.
So it is definitely possible, but it's an, what do you call, it's called an assimilation. Like, all pieces of software from all the world come together into it. And then you start to, they work as like a building blocks, and you start to build more and more. So probably an OS, they tinker with OS, like operating systems, internals and everything. So for it to work, yeah, probably 100 million lines of code is a fair estimation. So yeah, so given like a generic big company, corporate software life cycle, it usually has like teams. So each team does own a piece of software that actually, assimilates into a bigger one. And each team kind of has a very standard process, like to commit a code and how to run it, like how you have your own local development setup and how you test it and how you commit the code. It's almost generic to any company. So I've been like 3 or 4 companies, and it's almost like generic. So anytime you join a new company, there's an onboarding process for that piece of code that your team owns. So how to run it and all these things, and then at max, so it won't go beyond. And then, so you make some change, test it, and then there is a code review process, and it gets merged into the main code. And
what is the code review process? What happens during code review?
Yeah, code review is like, so every piece of code has some code owners. So there's always like code owners to, for example, in a code base, if you take, like, there are folders, right? So each of the folder will contain like 5 or 10 files or something. And each folder kind of is owned by like some people. So when the software evolves, like you kind of dedicate the owners, like assign the owners to those parts. And whenever you make change any of those folders or something, so Git, any of the Git systems like Git, GitLab or whatever. So they basically know who the code owners are, and they get a notification like, this code has been changed, please review it. And then you can clearly see like what has changed. So you call them diffs. So you can clearly see what has changed, and then you kind of review. They review usually based on like how clean, or is it the best way that you have done? Can it be more performant? And all of these things. So yeah, this is just to make sure that, even a small line of code can completely crash down the system, right? So
that's what I was about to say. So even the number of lines of code you are mentioning are so large that it's very difficult to find out what went wrong. Right? So I think there should be many systems to understand what wrong when something goes wrong.
Yeah, I speak to a lot of people like in Google, Facebook, and a lot of all the top tier companies that people consider. And they follow a very standard approach. So it's always like make a change, put a dev, code review, and then senior engineers, staff engineers, they kind of review, and then they'll put you some feedback.
Protocol on what gets into the base and what gets rejected.
Absolutely.
Okay.
Most of the time, you don't get rejected, but it will be lot of back and forth. Like if you deal with a really solid staff engineer or something, like then you'll have to do back and forth like 10 or 15 times.
Okay.
And there are also like there's certain, each of the company has its own culture of like writing those code reviews and comments, because it also depends on the tool. Most of the people use like GitLab. Some people use even GitHub. In Twitter, for example, there is something called Arcanist, so which is actually derived from Facebook. So Facebook initially launched it, and it's being used in the industry now. Not sure, but it's almost like 10 years now. So this Arcanist is also like a diff tool, and you have a different mode of writing those comments. So you can also say it's like a nitpick. Like if you say like if you put a comma and if you didn't put a space or something like that,
Okay.
it's a nitpick, right?
Okay.
So you get easily offended. Like if you do a code review, like going back and forth 10 times, you'll get offended.
Yeah.
Why I'm not able to push it? Like, why can't you just accept it? So this tool has these specific tools, like you can say nitpick, and you can also say like foist. Like if somebody is not reviewing your code for like a couple of days, you can just like put a foist on that, and it will become like more serious, and it's like top and red color for him to kind of do a review.
Okay.
So each has its own tools. Yeah.
I think, from what you are saying, so software itself is a piece of code, and also it has a life which evolves.
Yeah.
It's kind of a persona which needs to be maintained.
Yeah, absolutely. Yeah. Each culture like brews its own personality, right? So this is what you like. If you go into two different companies, they have like completely different processes. There are some meta level processes like code review and how the teams are structured and what amount of code they are made. Some companies, for example, like Amazon and a lot of companies are moving towards service oriented architectures. What you call is basically each piece of code is isolated into its own service.
Okay.
So each service is like completely independent. Like it's a piece of software that runs independently on the separate hardware dedicated to it.
Microservices.
Microservices, yes, that's what service-oriented architecture. Yeah, so it has its own personality. Like you go into like, for example, I worked in like Booking, for example. The code base is completely different, the way it is written and stuff. And you go to Amazon, for example, it's completely different. It's more service-oriented and microservices and all these things. And yeah, in Twitter is also like completely different. So we deal with systems mostly that run on AWS. So there's a partial migration going on in terms of there is an in-house cloud, and also there is a part of systems that run on Google Cloud and Amazon. So we majorly work on like AWS side. The infrastructure and deployment is slightly more completely different from what in-house is. So everywhere you go, you find different personality for that software. Yes.
So and to keep that personality intact, so there will be a lot of processes in place, and there will be dedicated people who kind of maintain the health of that software also.
Yeah, absolutely. The one thing I notice is like it's like who writes this piece of software? It's not like 100 people come together and write that piece of software at once. So it usually starts with like 1 or 2% like trying to do something like make this piece of software. And then it incepts from that point, right? So it's always like that. So the culture is kept by those like core people who mostly are like principal engineers and stuff. So they keep the code in certain specific format. So that's how like I see. That's how why I think like each software has its own personality. So these core principal engineers, they differ. They kind of maintain the code. Certain policies has to be put in place.
It's kind of those engineers' personality getting translated to that code base and giving a shape to.
Yeah. All the tools and all the decisions that the company takes. Yeah, usually it comes from like very high-end chain of command. Like chain of command is like two ways. Like there is also like people chain of command, like the CEOs who take care of the company, overall company health. But there is also chain of command in the software, like from the CTO to the ground level stuff. So yeah, most decisions are on very core people who wants to keep the company at a certain personality. So yeah, that's very unique, and it will be really interesting. Like if you like shift companies, which I had like good amount of.
You have worked to start at the career starting. You worked in Cisco later
Yeah.
Amazon.
Yeah.
Then I think you shifted to the gaming company called Kiwi.
Correct. Yes. Yeah.
Post that you worked on multiple startups and after PaySafe and from there booking from to Twitter. I think you have seen in all genres of like code bases are organized and how they build their own.
I shifted too many companies, but so I had that privilege just to talk about like how each kind of company has its own software. So looking it from the outside is completely different from looking it on the inside. So
it's like getting insider perspective of how great products are built, like from games to like social media platforms to e-commerce to logistics to network. So all the 5 top categories of companies you have. You have got an insider perspective, is what I believe. So one silly question actually. So over that time, like right when you have started writing your first line of code, solving your C assignment, or maybe before that, and till date, is there any approximate number on how many lines of code you might have written?
Yeah, it's a fairly interesting question.
So I know you have built like 10 to 15 products on yourself as a side hustle and worked on multiple startups. So I know a fairly large amount of work has been gone into, and I know Abhinav works for 20 hours a day. So in that he codes for 40 hours.
That is what I'm trying to look at it like very objectively and trying to estimate. So I never thought of it this particular question. So if I'm like in like
it should be millions is what I believe.
No. That is what, like, why you make an estimation. So it's like I'm like 10 years into this software. So 10, 12 years, for example. I've been writing code on an average of like 50 to 100 lines, maybe. So let's say like 50, and then you multiply it with like 10 years, 365 days. I've consistently written like every day, at least like probably 50 lines of code.
Definitely more than 500. What I believe, because from what I have seen in college, so
so it comes to what 365 into 10 into 50 is basically into 500.
Definitely in lakhs of code.
150,000 probably. Yes, not much.
It's definitely a lot more than what generally gets done, right? So it's still a big Cool. It's one way to look at, but more than the number, it's just a funny question. So, but more than the number of lines of code, I think we should see the impact of what the software has been doing.
Absolutely. That's one
right metric to consider.
That is true. So it's not just the number of lines of code. So some code lives on, some code like basically is useless at this point. So I believe so. It's always, and also like over time, like some piece of code is derived from another piece of code, right? So you will learn a lot of paradigms, you learn a lot of tricks, basically, they call. So those tricks, like they give rise to newer piece of software that is more resistant, more resilient to like dying. So that's how it is.
That lives longer compared to
You'll have to have a lot of experience, or you'll have to read, or you'll have to see what like really experienced engineers have written, and you can easily grasp them, and then you can use those tricks in the software, and then you can write piece of software that is more powerful, more resilient, and more it doesn't die. So that's how it is. So probably the last 10,000 lines of code that I have written are much more powerful than all the 100,000 lines of code I've written previously, right? Because out of experience, you learn a lot of things, and then that's how you build.
Makes sense, And while writing code also, everybody has their own style, is what I believe. Right? Can you tell an example, like any small example where this thing can be written in 100 different ways, like indentation? Kind of.
Indentation, for example, like early in my career, like out in the code reviews, I got to know about this indentation, right? So if you have like, generally companies follow do not exceed more than 120 characters in a single line, because if you write more than 120 characters in a single line, and if you put it for code review, it will all be mangled, right? So So they put this 120 lines so that you can easily see in one screen, two files and there's dips. So that is the standard practice they do. But you can compress it even shorter, write it even clean and beautiful. There are certain tricks like how you indent your code.
Okay.
You'll have to learn them, grasp them, seeing. Yeah, you just write like a big function that takes like 10 arguments or something. Then try to indent it like 10, 20 ways. Then you'll figure out like what looks better and what's not. Then if you look back your code, it's some of the code that you have tried is much more easier to read. So yeah, that's how you learn those tricks.
I think writing readable code is also an underrated art.
Yeah.
Is what I believe.
Yeah. Out of experience, people learn these things. So if 15 years younger me probably was taught this,
Yeah, I
somebody.
think I want to take cue from that. So 15 years younger me. So I'm going to ask you some questions like, what will be the suggestion you are going to give to your, I mean, these are the things you wish you know before you become a software developer. So now you understand them, but what are these things before you wished you know? So this will be helpful for our students. So maybe I'll give you some pointers to talk. So for example, there are many. I mean, if we search in YouTube or anywhere, there will be many kind of videos which says what a typical day of a software engineer looks like. So now I want to hear from your words, like how your typical day looks like. You have worked in many companies and you are one of the top companies in the world. So if we have to record a day of yours, okay, so how it looks like.
Yeah, I think a typical engineer's life, you start like 9, 10. 9 is like too early. Sometimes you start at 10, like have your coffee. Most of them drink coffee. I don't. So 10 is where you start and you'll have your lunch. Generally, you'll always have like some ticket or some project that spans like a month usually. Some of those tickets span even like few months. If you're working on a big feature or something. So you'll always have like 2 or 3 parallel things. So on an average, like you'll have it. And then, you keep pushing.
Parallel projects.
It depends like which kind of team you are in. Like if you are in a team which build like core features and sometimes like building a feature, making a migration, making a change, it spans usually like months, like 2 or 3 months usually.
Okay.
And then you also have like bugs assigned to you. And then you can take a look whenever you have time or when you're bored. But some bugs are like critical, like they block the release. So for example, Android, there's a bug in an Android code. And then every week there is a release. So every week at Friday, there is something called as like whatever the code is there currently, they start testing in the next week. So they what they call is like a code freeze, like Friday is the code freeze. So if you want your code to be there, you have to hurry. For some of the critical bugs or something, you have to hurry in the week to kind of like make it to that Friday 6 o'clock.
Okay.
And then the people start to go to release. Some of the features they don't actually have any timelines, so they span for like a couple of months. You can release whatever you want, but also there will be a lot of surrounding things because you cannot release the code as it is. So there are something called like features and there's something called as experiments, and you put your code in those experiments. So these kind of typical big features take around months. So you always have that ticket. So any engineer probably will have like one big ticket and one small ticket. So you keep working on it. So you can finish off early, like maybe 5 o'clock. But also you can finish off. You can work like 10 in the night. So it's not that
not every day is the same day.
Yeah, not every day is the same. Yeah, obviously.
Interesting way to see your impact in real time. Actually.
Yeah. Oh, these companies like big corporates have evolved to a point where you make a line of code change, you can get to know exactly how much of monetary value was there. Like for example, like booking is like a very is a critical, even in industry, people kind of recognize it's a platform for having this particular thing. So if you make a code line change, so you do some sort of like wrapping around the code, like if this, then execute this line of code. So what happens is like it clearly does an A/B experiment on a lot of people. Like you change the color of a button, for example. So you can put two different batches of people, like they call it like A and B, and you can clearly see that changing that color has actually made $100,000 for you. So that's the amount of impact that you can clearly measure. So there is tons of things that happen. So it's too big of a stack. There is a lot of statistics that run behind it, and a lot of things are there. But you can get to know how much monetary impact have you done. Like almost every company has it, like Google, Facebook, like Google, Twitter. Everybody has this experiment platform. So any change, you can clearly monitor the business value of it.
One more question I wanted to ask is like there definitely tons of languages out there. So the number of programming languages are like in thousands, right?
Yeah.
So when someone is starting their programming journey, so what would you advise them on these lines?
Yeah, it's too complicated at this point because there are 100. It wasn't this complicated. So usually, like for us, like for example, in our college, we started off with Python. So that's kind of like, so even I write Python every day and I really like the language. Times I also like C, C++. So I kind of like pick projects inside it, side projects or whatever. So I kind of do it. So even in my current work, I kind of deal with like a lot of C code. So for example, like Zoom and Google Meet, they all work on protocol called WebRTC, and it's written in WebRTC. Yes. So it's written in C because it has to be like super performant. There are tons of things that happen, like encoding, decoding, and a lot of things happen, and it has to be performant. So you have to write in C. So it's very hard, I would say, but whatever language is always like, any language is like Turing complete, right? So there is no language that you can do only specific subset of things and in a different language. It's a different art of writing. So all the different languages have evolved. I would, to be honest, it's a very hard question. Like what to pick? Like you can pick like Python, JavaScript, or C, C++, anything. But one thing that you will notice is like if you understand like just what a program is and what it does, 2 or 3 stacks down it. So there is a code that you write. What happens? If you just say like A equal to some 1, what exactly happens? In Python, basically, it's called a member object. So it's not just 1. If you write A equal to 1 in C, it's just like just a memory address as like 00001. And we can think about like what memory address, if you will call like 32-bit, 64-bit, what exactly. So it's the addressing this thing, right? So you'll have like 64 bits in any int that you put or something like that. So if you think about
2 levels down, 1 or 2 levels down, they're trying to write, then it will be very internalized, I believe.
Yeah, absolutely. So I juggle with like almost 4 languages here. So in my current work, I juggle with like Go, I juggle with C, I juggle with like a little bit of Java and Android, and there is Kotlin, and there is also iOS code that I have to write. So it's in like Objective-C. So you juggle with all these languages, but for example, the recent work like iOS, like I have to do some work on it. And then it's very easy. It comes very naturally. All you have to have is like basic for loops and basic like object-oriented programming, as like objects and functions and these things. So it's not very hard. Like I can pick up like a new language in like a couple of days, not more than that. But it comes out of experience, and it is just like that. So if you understand it deep, something well, so shifting to another language won't be a problem. So you can stick with whatever you have it. Think like 2-3 stacks down the line what happens, and then you'll naturally understand any other language in the world. So
maybe it's what called reading between the lines, probably. So
yeah, you could call that.
What happens behind them? Reading behind the lines, probably.
Yeah, and so one bad thing that I also like do sometimes is basically compare 2 languages. You can never compare 2 languages. Like for example, like I like C, and also Python. Like if you compare the performance, they are nowhere near. So Python uses like almost 100 times the amount of electricity to run a program that is written in C, right?
Yeah,
So, but the amount of flexibility that it gives is like nowhere comparable to doing something in C. Each one has its own purpose. And yeah, you can also like
these
think
things are
about
like
new
tools, and you need to pick the right tool for the job you're trying to do. Yeah, okay.
Yeah. It takes time, but you will evolve to that point, sure.
You'll try to find your way over the time.
Yeah,
So one more vanity question I wanted to ask. So how many languages you might have experimented with till now?
Probably all the top 10 of the popular languages I have at least touched at some point in like last 15 years. Top 10 of those languages for sure. And there are certain things that I never touched, was Haskell, Pascal, and these kind of probably older languages, and some funny languages like there are lots of funny languages. Yeah, tiny programming, tiny things. These things.
Okay.
I probably never experimented with it, but I kind of see the fun in them.
Okay.
They're not practical. But the top 10 languages I probably have experimented, at least like I've written like a basic line of code. For example, recently I was testing with like a Rust to see like because the whole market is kind of like loving Rust. The whole community is like looking at Rust as like a next evolution of C, C++ and what it is. And yeah, it's not just languages. There's also like tons of frameworks. You take JavaScript, there are like tons of like Angular, React and all. Tons of things. They have a completely different paradigm of writing it. They actually force you to think in a particular direction. For example, Rust was one particular language. So you cannot write a normal piece of code. You can write definitely, but it actually forces you to think in a specific way that doesn't make you do simple bugs. For example, in C, there are a million ways to actually crash a program in a segmentation fault. But in Rust, it basically forces you to rewrite the program. So there is some called as like static type checking and there's a lot of static checking that happens. So each object has to be actually freed before you pass on to different things. So even C, C++ have evolved to use the smart pointers and all this. But yeah, so Rust is one specific thing I was looking into. Yeah, it's always interesting, and it's always evolving, changing. But stick to one language, you will learn all the others easily based on the need.
And over the time, you'll get to the learning curve of learning a new language will reduce over time.
It will drastically come down. It will be not more than a day or two. Like if you stick to one language, learn like 1, 2, 3 levels down the stack, what happens? Any new language won't be a problem at all.
Okay. I think that's a good point of view. And also, one more question I wanted to ask, like nowadays, like having a computer science degree, I mean, many companies have dropped the requirement, Google, Apple, and I think most of the big companies have dropped the requirement of like mandating a computer science degree for the software roles that they are. So, like, what do you think? How much it helped you, or what's your take on it?
Not sure. It's, to be honest, my degree actually never mattered. Like applying for a job, changing jobs, at least like anywhere, like entry level, probably they'll check just to like, bias you, like to put you in a bucket where you are at least capable of. So probably it's needed. But maybe 4 or 5 years into the career, it never matters. Nobody has asked for me a degree or like how much, what did you even study? Nobody did ask. So you pick an interview, you put your resume out, people see it, they like it, they interview you, and you present yourself well. If they like you, they just hire you. So it's never about the degree. But you have to have some computer science experience, right? You can put it in any format. You can put that you have like 10 GPA in computer science. Or you can say like, I did this project, I have experience with like, I know how a system works and all these kind of things. If your resume presents that specific thing, I would definitely hire it. So even when I'm sitting on the other side of the interview table, when I look at a resume, I never look for a degree or what they mean. So I just look for something interesting that they have done, or at least that gives me a signal that they have some computer science experience. So that's all matters to me, to be honest. Yeah.
And I wanted to ask you something else. So, for example, you have been into engineering from very long time, like for example, building projects, trying to decode, debug, creating something new, experiments, and all these things. So did have all these things had any impact on your mindset? I mean, over the time?
I would say definitely, because I spend a lot of time. Like, you have to build a project, you have to plan for it, and it's almost like taking care of a new organism. It's like a new pet of yours, and then you have to take it. So you'll definitely learn a lot of things. And also, like, if you're building something, if you understand like a product, putting out in the market, the way it works and all these things, will definitely give you more broader understanding of how world works. And if you interact with any piece of software, you install like something on your laptop, it's done by some people, and you kind of understand the economics of it and how it works and how the world works, you kind of get to know. So
Okay.
I think any profession has it basically, but
Exactly.
software has like a slightly more easier and better feedback loop than anything. Like, if you are a painter and artist, like, you can understand how world works using your profession. You're a software engineer, there are a lot of easy things, because right now everything works on internet, right? So you can get to know easily, you can learn everything easily, you can put anything out easily. So at least in terms of mindset, being a software engineer has much more upsides than any other profession, because quite easy to get the feedback, learn about the world easily. Yeah.
I think, yeah, that's a good like correlation. I mean, I also believe in that fact that if you understand one particular thing in depth, like to truest sense of it, try to understand what exactly it is, then you kind of relate to how exactly everything else works.
Yeah, definitely. Yeah, everything is connected. You can go deep down into the philosophy, and then, but yeah, over time experience, you will never understand. It's very hard to understand. Some people are gifted; they'll understand like 15 years younger than me. Probably would understand how world works and how to do it. Those are probably the CEOs and all these people that you see and you look at as role models. So they probably figured it out much early in their life. So some people have like their own learning curve, their own way of looking at things. So yeah, but eventually everyone evolves to that point and see like how world works.
True, definitely. And also, I was wanting to ask you one question, like how I mean, I am fortunate that I got introduced to Twitter in the early time. So after Google and Wikipedia, so I attribute most of my learnings to Twitter. So it's because of whom I followed on Twitter. So it brought me, it has given me some new perspectives and how to look at the world and how to read things and all these things. So this is an outsider perspective of how Twitter is. So maybe I want to hear from you, like how insider perspective will be, like, for example, how the culture is at Twitter, or how things work, this kind of things.
It's for me, like, I've shifted to different companies. So particularly like Twitter is much more cuter ecosystem than others, because most of it depends like how the culture is kept, right? So Twitter culture is mostly, the way that I see is like mostly senior and staff engineers and interns. So there are not many engineers who are like very early in their career. So the exchanges between the engineers and stuff, it's mostly much more highly intellectual than any other like companies that I've seen. So in that way, I think Twitter is like a completely unique. It's more of a older, experienced product engineering culture, I would say.
More matured and experienced.
Yeah. That's my perspective, but there could be a lot of different teams who have like different engineers. But it's mostly relaxing, mostly slightly more intellectually relaxing in terms of like, you are not bombarded with like tons of like stupid things. Sometimes you feel stupid sometimes, but not at Twitter that I've experienced. So it's always like slow moving and experienced people doing their things.
Okay, it's kind of maybe doing a sculpture in an organized way, a kind of thing, building a sculpture kind of thing, probably.
Yeah,
which looks good over the time. So every day you might not be able to see the change, but over the time you see a big difference.
Yeah. a lot of companies are like very fast moving, and a lot of things like shitty code gets committed and it breaks, and then you fix it. There's a lot of what do you call, like the
To
ecosystems, like, yeah. So it's much more dynamic, or the chaos is much more higher. At Twitter, I've seen like lot less chaos.
Okay. Good. And yeah, I mean, I know it's already too late for you. You have had
Yeah.
a very tiring day already, and yeah, and
Yeah, yeah.
thanks to you for joining us from Netherlands. And yeah, I mean, you have talked about many important things today. For example, how a software. I mean, the main crux takeaway for today is how a software should be seen. Like it should be seen as a persona in itself. It will have a life, and it will have a particular purpose, and how different people try to maintain it. And
Yeah.
it's good to learn about some of the key terminologies, like how code reviews happen and how different
Yeah.
cultures be. And
Yeah.
and also I think you have thrown light on like what are the things students need to keep in their mind while learning a new programming language and all. But before I kind of leave you, so I want to ask one more question. So
Okay.
is there anything you always wanted to say to your younger self? For example, that is
Yeah.
what I want you to share with
Mm.
students.
Yeah, it's an interesting question actually. Yeah, so younger self, me, I would say, for example, like 15 years ago, like my perspective of looking at the world is like not looking very deep into how software works because it's too early, and yeah, that was very natural. But also not be feared, right? So at least on the interview side, I would say like 15 years younger me is probably like thinking about like career and all these things, like much more tense. But it's not the reality, to be honest. The the one who is interviewing is not that experienced, to be honest. So he is also on a learning curve of his own. He's like definitely experienced than the people who are being interviewed, but they have their own learning process. They are also on their own learning journey and stuff. So if I would actually, I learned it much early in the career. So I was never afraid of like being interviewed, like because so I look at like interview as like just like go to the interview first, and then we'll figure out, be there, do whatever it takes, kind of thinking I had. So that a lot of people I miss, like people that I interviewing, also kind of miss that fact. So they're always scared. They don't take like bold moves. They don't take the feedback well and these kind of things. So 15 years younger me, I would actually probably push like interview early, do as many interviews as you can, and try to be fearless. Make some, yeah. If you are being interviewed, if you are asked to write a piece of code, take bold moves, like think big. So that's what I would probably kick my ass 15 years ago. Yeah.
Okay. I mean, you related it with an interview experience, but the message you wanted to give is to be fearless and do
Yeah.
the thing you always wanted to.
My point is like you would definitely want to work with people who are fearless, right? So you have to be fearless to be liked. So that's what I think. Yeah.
Definitely makes more sense.
Yeah.
Okay. So yeah, I think I'm already holding up. So you
Yeah.
must be late to another meeting or another side hustle of
Yeah.
yours. Sure.
Yeah.
So
There's always that. Sure.
yeah, and thanks a lot. Thanks again for joining us today. So I'm
Yeah.
definitely I'm sure that students have learned new things. At least they have got many new different perspectives of how things work at large scale. Okay, so
Mm.
some interesting numbers and interesting stories. So
Yeah. Yeah. Hopefully, yeah. It's quite interesting. Yeah. Thanks for inviting me. And yeah, hopefully it helps somebody.
yeah, and yeah, so yeah, we'll meet you soon, and hoping to host you again. And I'm sure our students will shower their love on you. And
Mm.
since it's going to be Diwali, you are
Mm.
going to experience Diwali on your LinkedIn. So
Oh my God.
they have a way of sharing their learnings from the
Okay.
podcast. They kind of
Mm.
show their gratitude to the speaker. So
See,
that's
you have your own culture of your own company. So yeah,
yeah,
it's nice.
yeah.
It's
So
pretty good and quite interesting.
Thank you. So thank you so much. Thanks again for joining. Yeah. Good. Have a good
Right.
day. Bye bye.
Today too. Bye. Bye.
Thank you so much, students, for joining us today. And I hope it has been a very interesting discussion. So this is very special to me as well. And we got to chat on a vast variety of subjects today. So starting from a process of evolution to how a software development life cycle works. So it's kind of interesting to learn from an experienced person like Abhinav. So and once again, like you had, I hope you had a very good learning from today's podcast. And I wish you all a very happy Diwali and stay safe. And also hope this Diwali brightens your day and it signifies something new. So be consistent and happy learning. Thank you. And hope to see you in the next podcast soon.